Hello LSP, this is the second video in the Microphone Essentials review. Moving on to Super and Hyper Cardioid. These microphones are polar patterns, are slightly more directional than the cardioid. Of course, they trade off a rear lobe, sensitivity in the rear, for increased tightness in the front. This drawing here is a Shure Beta 87A. It is a super cardioid microphone, and you can see that it has kind of a cardioid pattern in the front, but it's a little narrower side to side, but it's got this rear lobe, so it does pick up from the rear. They are two different types of polar patterns, super and hyper. Super is a little bit more like cardioid, and hyper is a little bit more like bidirectional. So there's a continuum here that goes omni, cardioid, super, hyper, bi. And really it's the ratio of the pure bidirectional figure 8 pattern versus the pure omni pattern. And different ratios make different polar patterns. So super, of course, is a little bit narrower than cardioid, but has a rear lobe. Hyper is even more narrow, but has quite a lot of a rear lobe. And so in live sound, we tend to see a lot more supers than hypers. Supers are going to be a lot more effective because the rear lobe is not out of control. This slide here does show some of the specifics. Important thing to realize here is that hypers actually only have 6 dB of rear rejection compared to the front, whereas supers have 12. So supers are, 12 or 6 dB, or twice, if you want to say that, twice as much, more restrictive in the rear. And in this slide also shows the ratios that hyper have a 3:1 omni to bi ratio, whereas a super has a 5:3. So the ratio is kind of important. It does show you how directional the microphone is. Now, it's not, supers and hypers are really useful in live and in studio for miking complicated instruments like drum sets. I like them on tom-toms. The cymbals are really close, so I prefer to use supers on toms because I can put the cymbals off to the side and the cymbals will splash at the null or the dead spot in the microphone. So other places you might want to use hypers and supers, horn sections, you got a bunch of horns standing next to each other. This might restrict the horn next to it coming into the microphone. And specifically if you're not worried about a loud wedge, supers can be more effective than cardioid. It isn't just about the instrument design, it's also about the wedges you need to think about when doing polar patterns. Sometimes artists want to use 2 wedges directly behind a microphone. From a sound guy perspective, this is kind of rough because the two speakers tend to interact, making kind of complicated spatial combing, and the potential for feedback goes up dramatically. But if you are in this situation, the artist says, I want 2 wedges. If you're using a traditional cardioid microphone like an SM58, put them behind the microphone so that the wedges are pointing at the dead spot, the rear null on the directional cardioid. If the artist wants to curve them out, which typically they do, this is a great time to switch to a super cardioid like a Beta 58A, which is a very similar sounding microphone. And when you run across an A in Shure lingo, that is always a super cardioid, and so that's a good thing to know. A lot of Shure microphones, a lot of Betas specifically, are super cardioid because they're effective in that regard. So point the wedges at the sides of the mic. This polar chart drawing here shows this even more effectively. Here's the polar chart of an SM58, and you can see if we pick a frequency, of course every frequency is slightly different. You can see down at 125 here it's ominous omni. When we get up to 2K here, a nice frequency that likes to feed back, it's pretty much cardioid, and the rear lobe is pretty intense here on the microphone. It's that solid line right there. So obviously if you're using a 58, point the wedge at the rear. If you're going to use multiple wedges pointing from the side, or if you're going to use, it's time to mate them up with a super cardioid, and in this case have the 2 wedges point at the side of the microphone and kind of avoid that extra rear lobe there that picks up. This is a 3D effect. This isn't just 2D. So you want to think about this on the vertical axes as well. The wedge pointing at the null here is very effective, more effective to the tune of another 6 dB of gain before feedback, whereas tipping this super cardioid microphone, this is a Beta 58A, I can see with the blue stripe there, pointing this at a wedge like this would be, kind of bad news because you are now directly picking up the wedge. There's more to polar patterns than just wedges. proximity effect plays into this at all as well. Proximity effect is rather complicated to explain. It's a combination of inverse square law, the design of the microphone, the tuning of the capsule, how the ports function, the distance of the ports, how much soft goods is inside the ports. It's rather complicated, but the bottom line is that proximity effect means the closer you get to a directional mic, the more low end you get. And in non-directional mics, which of course is an Omni, see no proximity effect. And this can be really effective to use in, say, a microphone that's shoved in someone's mouth, like a headset microphone you might see on Broadway or in a lecture or something. A microphone that's going to be really close to someone's mouth, and Omni is really effective because you're far away from ambient noise, and it's going to be more consistent. Supers and hypers have a more proximity effect than cardioids because they're more directional. Bidirectional figure 8 mics have the greatest amount of proximity effect. So the more directional you get, the more proximity effect you get. And this can be a good thing or a bad thing, and you can use this to your advantage. You can pick an Omni or a figure 8 mic if you want more or less of that sound. In fact, going back in time, back in the 1930s, 1940s, the crooner singers, think Sinatra, Bing Crosby and all that, they used this to their advantage. They could get up close on that microphone and get that low-end impact, which was part of that sound of that style of music. We use proximity effect in the modern era. We love putting them on drum mics. We put them really close to the snare, really close to the kick, and get that extra low-end impact. And of course, DJs and vocalists like that low-end boost, get extra manliness you get out of that chesty sound. One more thing to think about with polar patterns is reach. Reach is not a real thing. It's just a way of thinking about polar patterns, and it's the fact that the more directional you get with a microphone, the further you can pull it back from the source and get a similar ambient noise to source ratio. So omnidirectional, this is intuitive here. Omnidirectional microphones are more likely to feed back because every direction is the same, has the same sensitivity. But if we go here to hyper, hyper is going to really focus on the front, so you can pull the microphone back. This could be really effective in, say, a choir where you can't stick the microphones right in front of the singers, or you have to pull them back 10 or 15 feet because of sight lines or whatever. Definitely time to switch to a directional microphone and take advantage of this reach, this rear to front ratio and how it affects ambient noise. So again, reach is kind of a way to think about it. It's not a real thing. You're not going to see it on spec sheets, but it does help you conceive and think about polar pattern usage in your microphone applications. All right, on to the next video.